Good day, everyone. Before anything else, let me introduce myself first. I am Miss Alondra Sidvilla, a student teacher under with care of Ma'am Heidi Suarez in Natalia V. Ramos Memorial Integrated School. We are now down in week 7 of quarter 3 in Mathematics 8, and this lesson is about proving statements in triangle congruence. Join me as I will tackle this lesson and it will serve as your guide in answering learning tasks. Here are our objectives of the lesson. So we have identify statements on triangle congruence, apply the postulates and theorem on triangle congruence to prove statements. So as we go on this topic, you were expected to manifest this and learn more about proving. Let me ask first a question to you. So what are the definitions, postulates, and theorem that you still remember? I know in the past lessons, definitions, postulates, and theorems were discussed. So what are those that you still remember? It is good to recall your past knowledge because we will going to use that in proving statements. So now, let's identify those and hopefully some of I will mention are saying what you remember. So here are some definitions that were tackled or mentioned in your past lessons. So we have midpoint, angle bisector, segment bisector, equilateral triangle, perpendicular bisector, and also vertical angles. So we are going to use that to support our statements as we go on improving. And these are just some of the definitions. So there's still a lot of definitions in geometry that we may use in proving. So also we have in theorems that were part in your lesson that will also use to support statements, improving statements. So we have here right angle theorem, which means that all right angles are congruent. And aside from that, we also have vertical angle theorem, which states that all vertical angles are congruent. And aside from theorem, we also have triangle congruence postulates. So we have SSS, ASA, SAS, and AAS. So this will help to prove that two triangles are congruent because it is true at all times. So I hope that this helped for you to recall of the different postulates, theorems, and definitions because we are going to use them in proving. Aside from what I presented, so in the triangle congruence postulate, in the definitions or in theorems, there's still a lot. Okay, there's still a lot that were not mentioned. So we are going to recall them as we go along in our discussion. So are you ready? If you are ready, let's begin. So we have here example 1. So we have here our given and what we need to prove, and also our figure. And in our lesson, in our improving, we're going to use two-column proof to prove statements in triangle congruence, wherein there are statements and reasons. So, like this one. So we have here our statements. Here is our statements. And we also have the other column is the reasons. So here's our. So the first thing to do when we are proving is to identify the given. So we have line PU is congruent to line PH. And our reason for that, it is our given. Ano pa? And aside from that, we also have another given, right? So we have here line SU is congruent to line SH. Same reasons, which is given. So let's put marking on the figure so that we are guided. Put here 1 and as a sign, these two sides are congruent. And also aside from that, we have also SU. Let's put two markings on that. And SH. Let's put two markings. Okay. So now, since we put markings on that and we already identified the given, so let's remember what we need to prove. So we need to prove that the triangle UPS here, triangle UPS is congruent to triangle HPS. So UPS is congruent to HPS. So let's recall from our previous lesson. So how can we conclude or how can we prove that the two triangles are congruent? You still remember? So in proving that two triangles are congruent, we should know that there must be three, right? Three congruent parts on the two triangles. So let's analyze again the figure. So what other information can we get in the figure that we may include in our statements? Can you see that the triangle UPS and the triangle HPS share a common side? So what side are they common? Yes, they are. If you answer line PS, then you are correct. So we can say that the line PS is congruent to line PS. And our reason for that, so recall from our previous topics. So what postulates, properties, or theorems, or anything that will support our statement, which is that line PS is congruent to line PS. So what must it be? It is reflexive property. So what do we mean by reflexive property? So reflexive property of congruence states that an angle, a line segment, or shape is always congruent to itself. So based from this, that line PS is congruent to line PS. So line PS is congruent to itself. So it satisfy our reasons, which is our reflexive property. So let's put markings on the figure. So line PS is congruent to itself. So let's put here 3 markings. Let's assign that it's the third congruent part. So let's analyze again the figure. Can we prove now that the triangle UPS is congruent to triangle HPS? Yes, we can prove now because we already have 3 congruent parts, right? So we have here that the line PU is congruent to line PH, SU is congruent to line SH, and also the line PS is congruent to line PS. So we can say now that the triangle UPS is congruent to triangle HPS. So what must be our reason? So again, recall your past lessons about postulates, theorem, or definitions. So what must be reason that will satisfy our given statement here? So what are those postulates? Postulate the triangle congruence. Or you can also be guided on this figure. So what must be our reason? SSS postulate. Because in our SSS postulate, the three sides of one triangle are congruent to corresponding three sides of another triangle. So as you can see, it is satisfy our reasons for our statements. And that's it. We proved that triangle UPS is congruent to triangle HPS. Always remember, when we are proving two triangles, we must first identify the three congruent parts of the triangles. So there must be a process on how we're finding the statements and identifying the results. So now let's proceed to our next. So we have here a question. So is it possible to go further after proving that two triangles are congruent? What do you think so? Yes, because proving two congruent triangles does not end on that. We can go beyond it. So, we have here a question. What is CPCTC? When we say CPCTC, it stands for corresponding parts of congruent triangles or congruent. And it is commonly used in the near end of a proof to show that the two angles or two sides are congruent. So once we identify that the two triangles are congruent, we can use the CPCTC to identify those that are not mentioned in the first proof, or the first three proofs are in triangles. There are two steps to prove statements about congruent triangles. First, prove that two triangles are congruent. 2. Identify their corresponding parts and use CPCTC to conclude that these parts are congruent. So always remember to prove that two triangles are congruent first before identifying the corresponding parts and use CPCTC to end the proof. So let's have another example. So our example number 2, and here is our given. Line AM is congruent to line BN. Line BM is congruent to line AN. And what we need to prove is that angle M is congruent to angle N. So let's put first, always remember that the first thing to do is to put the given on our statement results. And given. And let's put markings on the figures to show where are the congruent parts. So here, line AM is congruent to line BN. Let's put one marking on each. And also we have line BM. Here, let's put the second markings. Congruent to line AM. Okay. So now we identify two congruent parts of the triangles. Always remember that the first thing to do is to prove that the two triangles are congruent. And as you can see on the figure, we already have two congruent parts. So let's analyze again the figure and find where is the third congruent part of the two triangles. So where do you think so? Okay, can you see that the triangle AMB here, triangle AMB, triangle, I mean triangle is the triangle itself, is triangle AMB and triangle B and A share a common side. So what side is it? If you think that it is the AB, then you are correct. So they share a common side, line AB. And we can say that AB, line AB is congruent to line AB. And what is our reason? So what postulate or theorem or definition or properties that support our statement here that the line AB is congruent to line AB? It is reflexive property. Because when we say reflexive property, it is states that an angle, line segment, or shape is always congruent to itself. So which means that the line AB is congruent to itself. And again, let's put the markings. So let's put here the third markings. And what can you see now on our figure? We already proved the three congruent parts, right? We already proved the three congruent parts of the two triangles. And now we can prove now that triangle ABM is congruent to triangle BAN. So what is our reason? What will support our statement here that the triangle ABM is congruent to triangle BAN? So when you see on this figure, we have three congruent sides, right? This is the first sides, the second sides, and the third sides that correspond to the other three sides of the triangle. And our reason for that, SSS postulate. Because in SSS postulate, it states that three sides of one triangle are congruent to corresponding three sides of another triangle. Did you notice that it support our statement? And now we can say that angle M is congruent to angle N. And our reason for that is CP-CTC. Because once we prove that the two triangles are congruent, then all corresponding sides, all six sides, since we have three sides three sides and three angles of triangles. So we can now say that angle M is congruent to angle N by CP-CTC. So let's now have another example. So here is our third example. So our given is line BD bisects line AE, and angle A is congruent to angle A. And what we need to prove is that angle D is congruent to angle B. So the first step is to put our given on our table. Our reason is given. And now since we identified the given, let's now first put the markings on our figure. Let's put markings on our figure. So what we can use in our given is this one, our second example. Our second given, which is angle A is congruent to angle E. So let's put markings and angle A. Okay. Now we use our second given. So our first here given, we cannot put markings on that on our figure since it does not says any congruent parts. So what we can do on our here first given is to use this to find our second statement. Okay, so when we say line BD bisects AE, so in bisects, so it means that bisects into congruent parts. So cut into two equal parts, so which means that line AC is congruent to line CE. And what must be our reason for that based in our first statement? So our first statement and our second statement has a connection. Because we arrive line AC is congruent to line CA based from this. So what our reason for that? So what will support our statement that line AC is congruent to line CA? It is definition of segment bisector. Because when we say segment bisector, it is a line, array, a line segment, or a point that cuts a line segment at the center, dividing the line into two equal parts. So you can see it satisfies our statement here. So if it is satisfied, then we can put markings on our figure since line AC is congruent to line CE. So let's put our second markings on that here. Went to CE. Since we now have two congruent parts of our two triangles, then we must find where could be our third congruent part for our two triangles to be congruent. So let's analyze again the figure. So where could it be that the third congruent parts? So as you can see here on our figure that there is a vertical angle, right? Vertical angle. So when we say vertical angles, these are angle ACD and ACB, angle ACB. So we can say that angle ACD is congruent to angle ECB. So what is our reasons if there are vertical angles? Our reason for that is vertical angle theorem. Okay, so when we say vertical angle theorem, it is state that all vertical angles are congruent. So if they are congruent, then we can put markings on that. Let's put our third markings on that. Here, the third, here, like that. So as a sign that signifies that they are congruent. So let's analyze again the figure. And as you can see, we already have three congruent parts. This is angle, sides, and also an angle here. So if you have already three congruent parts, then we can now say that triangle ADC is congruent to triangle EBC. And what is our reason? So what postulate does our two triangles fall? It is in ASA postulate, right? Because in ASA postulate, it says that two angles and the included side of one triangle are congruent to two sides and the included angle, the included side of another triangle, then the two triangles are congruent. Since we already proved that the two triangles are congruent, then we can say now that what we need to prove here is that what we need to prove is that angle D is congruent to angle B. And our reason for that, we will going to use the CP-CTC. because once we identify that the two triangles are congruent based from the three parts, so all corresponding parts, all six parts of the triangles, all three sides or all angles, three angles are congruent. So now, since we have done in our example number 3, let's have an activity wherein we're going to fill the our table of statements and reasons. So we have here our given angle ADT is congruent to angle ETD, and also angle ATD is congruent to angle EDT. So what we need to prove is that line AT is congruent to line ED. So we have already here our statements. Always remember, if the first statement here is our given, so which means our reason for that is given. And now let's put markings on the figure. Where are they congruent? So we have here ADT. ADT, let's use another color, yellow. ADT is congruent to angle AETD. So let's put here ADT, here, this one, and ETD. So here is our congruent, where they are congruent. And our second, we have here ATD. ATD here. So here is our second. Is congruent to EDT. EDT. So here is our second. So since we already have two congruent parts of the triangles, so what must be the next? And our next statement here, second statement, is line DT. It's congruent to line DT. So what is our reason for that? It is, yes, reflexive property. Because in reflexive property, states that an angle, line segment, or shape is always congruent to itself, right? So let's put here markings for that. Our third congruent part. And now next, our third statement here is the triangle ADT is congruent to triangle EDT. So what must be our reason? So we are talking here a triangle. So what triangle congruence postulate must it be? Yes, and you are correct if you says that it is ASA postulate. Because as you can see here on our figure, angle, side, angle. And this is the first in our first triangle. In our second triangle is you have your angle, side, angle. So when we say ASA postulate, it's two angles and the included side of one triangle are congruent to two angles and the included side of another triangle. Then we prove that the two triangles are congruent. So once we prove that the two triangles are congruent, so we can say that line AT is congruent to line ED by CPCTC. Because we already proved that two triangles are congruent, that all corresponding sides that were not mentioned are also congruent. Okay, so let's now have another example activity here. So we have here activity 2, and here's our given. Line GH bisects line EF. H is the midpoint of EF. And what we need to prove is that angle E is congruent to angle F. So in our first statement reason, we have here our given. So number 1. So what must it be? So it is that our given is from here. So in our number 2, we have here a statement that line AH is congruent to line HF. So it says here that the line AH is congruent to line HF. So what must be our reason for that? Okay, always remember, find the connection from the previous statement. So there must be a reason why it says here that the line AH is congruent to line HF based from our first statements. What is our reason for that? Our reason is definition of midpoint. Because when we say midpoint, it is a point that divides a segment into two congruent segments. So it satisfies here in our statements. Okay, so let's put marking on that. EH here, music purple. Put first here and here for first marking. And then next, in our third, we have in our reasons definition of perpendicular lines. So what do we mean by perpendicular lines? When we say perpendicular lines, it is a lines that intersect at a right angle or 90 degrees. It says is that 90 degrees angle. So what must it be? So you must find the two congruent parts based from the figure. So what must it be? It is that angle EHG here, angle angle EHG is congruent to angle FHG. I mean they are right angle. They are right angle. So let's put here as a sign that they are right angle. That means they are right angle. And then here in number 4, we have a statement says that angle EHG is congruent to angle FGH. So what is our reason for that? So it says is that they are congruent. So what must be is our reason? It says here that it is a right angle. So our reason for that is right angle theorem. Because when we say right angle theorem, it says that all right angles are congruent. And let's have our number 5. We have here in our reasons, reflexive property. So, what line or angle that will support here, support the reflexive property? Analyze again the figure. So, where the two triangles have common. They must be shared in angle or in side. So what is it? They share common in line GH is congruent to line GH. Since they share common here, right? GH here. Share. Okay, so if they are congruent, then let's put markings on that. Here. Okay. And now, since we already have uh, three congruent parts, right? Then we can say that triangle EHG is congruent to triangle FGH. So what is our reason for that? So what triangle congruence postulate will satisfy this statement? It is SAS postulate. Because when we say SAS postulate, it is if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the triangles are congruent. So as you notice, it satisfies in our statement. Now, once we prove that the two triangles are congruent, then all corresponding sides of the triangle are congruent. So when we have here angle A is congruent to angle F, then our reason for that is CPCTC. So based from my examples and my activity, I hope you understood on how to prove statements in triangle congruence. Always remember that to prove that corresponding parts of two triangles are congruent, we have to consider the following. First, analyze the given figure and statements. Number two is do not forget to mark the proven congruent parts. If you have proven two congruent parts, go back in the figure and look for another possible congruent part. Our number four, once proven three congruent parts, identify what postulate or theorem is applicable to use. And last, identify the corresponding part and end the proof by CPCTC. So always remember this because you will going to use this when you are proving uh, triangle congruence. So here is our week 7 that you need to answer. So we have here learning task 2. So remember we have here two numbers. So you're going to answer both of these in week 7. So aside from that, always remember to follow instructions based from WHLP because that is where we base in checking your paper. And that's all. And thank you everyone for reaching the end of my discussion. And I hope you learned a lot from me and you were able to answer the activities from the module. Thank you and goodbye.